Picture a stretch of tarmac so new the paint is still breathing, lit only by the blue pulse of sensor arrays buried beneath its skin. A single machine waits at the far end. No rider, no roar, just a steady exhalation of chilled hydrogen and the glint of LiDAR eyes mapping the darkness millimeter by millimeter. In the control bunker nearby, a neural net clock counts down. Somewhere in Tokyo, a biomechanical engineer is watching the same feed. In Munich, a designer reviews frame-by-frame telemetry. In Dubai, a squadron commander plots flight corridors that don't yet exist on any map. Tonight, these disconnected ambitions converge on one slender chassis of carbon lattice and liquid metal muscle. When ignition comes, it's not the thunder of pistons you hear, but a low harmonic ripple, like wind sliding over glass. The bike pivots, lifts 2 centimeters as the maglev base fields engage, and eases forward with the composure of a hunting cat. 30 microprocessors negotiate every wobble of Earth's gravity, while a quantum-tuned control core writes, revises, and rewrites a billion lines of code between each breath you take. But the road is only the beginning. Beyond the horizon lie altitude trials, autonomous duels, and a final sprint through a city that has outlawed noise itself. By the time dawn spills over the edge of the world, the line between rider and machine, asphalt and air, memory and prediction will have dissolved, leaving a single question in its wake. If freedom once meant twisting a throttle, what does it become when the motorcycle thinks first? For over a century, motorcycles have been loyal to a dangerous truth: speed demands risk. The faster you go, the more you gamble, with physics, with balance, with your life. But what if the machines we rode could refuse to let us crash? In 2016, BMW pulled back the curtain on the Motorrad Vision Next 100. A concept so advanced, the company declared helmets could become obsolete. At its core, a self-balancing gyroscopic frame powered by artificial intelligence that monitors terrain, tilt, and rider behavior, adjusting instantly to prevent slides, spills, or skids before they begin. It's not just a bike that stands up on its own, it's one that thinks ahead of you. Then came Yamaha's experiment, the Motobot, an autonomous robot designed not to assist riders, but to beat the best of them. Its mission? Outrace Valentino Rossi himself using only onboard sensors, AI prediction algorithms, and servo-actuated precision. The implications were unsettling: a machine that can learn to outperform the human body at its own game. And while others chased speed, one company focused on survival. The Damon Hypersport isn't just fast, it sees 360 degrees in real time, scanning traffic, predicting movement, warning the rider, and physically altering its riding position to match terrain or threat level. One moment you're crouched for speed, the next, the handlebars and foot pegs shift under your feet, adapting to the road ahead before your reflexes even register it. 3 bikes. One mission: eliminate human error. But if the thrill of riding comes from risk, what happens when the risk is gone? The more our machines protect us, the more they decide for us. And that raises a question even AI can't answer. When does the rider become the passenger? If safety systems reshape the soul of the motorcycle, then design is tearing up its body. This is where the impossible starts to look familiar, and the familiar becomes obsolete. Meet the Lazareth LMV 496, a motorcycle engineered not just to roll but to fly. 4 jet turbines embedded in its frame, a reinforced carbon fiber chassis, and a flight mode that lifts it from tarmac to sky in less than 60 seconds. What began as a wild concept for military scouts is now being tested by first responders and elite police units. Then there's the Honda Riding Assist E, which looks ordinary until you realize it never falls. Using balance algorithms borrowed from humanoid robotics, This bike adjusts for micro-instability, allowing it to track your footsteps, follow you in a parking lot, and self-correct its stance in a split second. And in the Nordics, a different kind of rebellion took shape. The RMK E2, a fully electric motorcycle with no rear hub. The motor is built into the rim itself, eliminating the chain, reducing drag, and offering seamless torque at zero emissions. It's part sculpture, part software. But these designs come at a price. Failures are frequent, costs are massive. One test flight miscalculation can ground an entire program for years. And yet, the pursuit continues. We're not just designing bikes anymore, we're solving sci-fi problems with real-world mechanics. We've only covered 6 concept motorcycles, and we're already defying gravity, eliminating balance, and questioning who's really in control. But tell us, which of these would you dare to ride? And which should never hit the road? Comment below, hit that like button if your jaw dropped, and subscribe if you're ready for the next 4 bikes. Because they only get crazier from here. The motorcycle has always been a machine of muscle and machine. But now, it's becoming something else. A thinking organism riding beside you. The Segway Apex H2 looks like a concept from a sci-fi film, but it's already in development. It runs not on gasoline but compressed hydrogen, powering a hybrid electric drivetrain capable of regenerative energy cycles and near-silent torque bursts. But its true breakthrough lies deeper, in a neural learning algorithm baked into its suspension system. Over time, the Apex watches how you ride, how you lean, how you brake. It adapts its stiffness, response time, and traction modeling to anticipate your next move before you make it. Across the world, another revolution is taking shape. The ZEC 00, an electric motorcycle from Japan with an alien posture and biomechanics-inspired steering geometry. Its radical lowrider stance allows for zero-turn carving, letting it corner like a snake sliding on rails. But underneath all this tech is a question we rarely ask. If your motorcycle knows when you're nervous, if it senses how much you sweat, how sharply you breathe, if it adjusts its behavior based on your biometric rhythm, then who is in control? And more importantly, who owns that data? Is it just machine learning, or is your motorcycle learning you? These bikes are faster, smarter, safer, but in exchange for that protection, they're watching everything. There comes a point where a vehicle becomes something else entirely. No longer a tool, but a symbol of what we're willing to risk, just to move differently. Enter the Hoverbike S3, a 4-rotor quadcopter-style motorcycle straight out of science fiction, built by Russian startup Hoversurf, and now patrolling the skies of Dubai. Capable of limited flight durations and vertical lift, the S3 is already being tested for rapid response teams in city environments too dense for cars, and too dangerous for traditional bikes. It's loud, unstable, expensive, but it works. Then, there's the machine that doesn't exist. Not yet. The Sphere motorcycle is a radical prototype still confined to patent filings and animation reels. But it proposes a complete redesign of locomotion. Omniball wheels capable of lateral, diagonal, and rotational movement, magnetically suspended inside transparent drive shells. The Vision, a motorcycle that doesn't lean or steer, it glides, rotates, and floats. Power, zero-emission magnetic propulsion. Fuel, unknown. Control, unimaginable. Is this science fiction? Maybe. But patents have already been filed in Japan and Sweden, and 3 major defense contractors are rumored to be reviewing the tech. If it ever sees the road, it won't ride. It will rewrite everything. But as we approach the horizon of what's possible, a new fear emerges. What happens if we can't keep up with the machines we build? We began with a question. What happens when we reinvent freedom? Now, 10 extraordinary concepts later, We've seen the motorcycle reimagined as everything from a flying drone to a sentient co-pilot. Each machine promised safety, performance, and evolution. But beneath the carbon fiber and neural chips lies something more personal. A reckoning with what it means to ride at all. When motorcycles first roared onto dirt roads in the 1900s, they were raw expressions of freedom. One engine, two wheels, and nothing between you and the wind. But now we're adding AI that adjusts to your emotions, navigation that reads your mind, and propulsion systems that defy physics entirely. Is that still riding, or is it something else? When a bike knows you better than you know yourself, are you in control, or is it freedom, reprogrammed? As with every great leap forward, there's awe, and there's fear, but perhaps that's the price of progress, because every era did redefine the motorcycle, from combustion to electric, from steel to silicon, and soon, maybe sooner than we think, from road to sky. But the final revolution may not be one of gears or gas, it may be something even deeper. A change not in the bike, but in the rider, in who we are when we let go of the handlebars. If this opened your eyes to where we're headed, hit that like button, subscribe, and ring the bell. This is just the beginning. From flying cars to thinking roads, the next frontier of motion is already here. And we're going to ride every step of the way.